I could actually draw this here and say, okay, this is my x sub c, right? And this is my y sub c. Draw that in, because I don't think I drew that in. So just as a reminder, here's my body, here's my x sub c, here's my y sub c, over somewhere else, any axis other than through the centroid. It could be right here, x prime, y prime, y prime. It could be here, x prime, y prime. Any axis that doesn't go through the centroid is another axis. So if we want to find the moment of inertia about the x-axis through the centroid or the y-axis through the centroid, how do we know what the moment of inertia value is? Where do we find that? On the table. As long as we want to find the moment of inertia about the centroid, we look on the tables that you have. But if you want to find the moment of inertia about an axis that's not the centroid, so it's any axis not the centroid, I'm going to just write center, then what do you have to do? You have to use the parallel axis theorem. Which says what? Parallel axis theorem says we need to know this guy anyway, right? And then we have to add on a piece. So let's take a look at this problem. If I want to find the moment of inertia about x sub c axis or y sub c axis, how am I going to find the moment of inertia? The table. If I want to find the moment of inertia about these axes going through the centroid, I'm going to find it at the table. Okay? But let's say I wanted to find the moment of inertia about this line right here. What do I have to do? Parallel axis theorem. How about if I wanted to find it about here? What do I have to do? Parallel axis here. Parallel axis here. Anywhere. Vertical. Here, 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 here. Anywhere that is not through the centroid, I'm going to have to use the parallel axis theorem.
So do we have to do it twice if you wanted, if it was off the center on the y-axis and off the center on the x?
You're going to have to do it twice.
Yeah.
Because you're going to have to do the x and the
And
y.
the y, okay.
Okay? But these problems are zeroing in on one thing. So even though I have the math all written out, I'm going to write it out again. So what do you think? You think we're going to solve this using a table? Yes. What's the first column going to be? Section. What do you think the second column's going to be?
Area.
Area. And let's always put the units. What do you think the third column's going to be?
Perpendicular distance.
It could be. Let's do these guys first. We already have these down, right? Section 1, 2, 3, 4. So read this out to me because we already did this on the, don't you move this? We already did this on the first part of it, right? Where are we? Evan, I think we're up to you. Could you read these numbers out to me? Well, first the units are, is it meters squared?
Yeah.
What's the area?
.055
Okay,
and .04,
okay.
.12, .04.
And I guess I shouldn't be covering the picture though, right? Because we're looking at this picture here. Kyle, could you just move over so I could, What?
Oh, that's what I just did.
Can you pan left for us?
I want to make sure you can see that too. How about we do the moment of inertia next? Oh, first of all, what is the problem when I find the moment of inertia about? So where's x prime?
0.4.
It's up, well, it's not up 0.4, it's up
It's sensitive.
0.05 plus, oh, they want us to find that. So it's the centroid. Let me just put my glasses on, I'm sorry.
One day I can have classes.
Yeah, they want us to find it about the centroid. So locate the centroid, which is y bar, and then they want you to find the moment of inertia about the y bar. So they want us to find the moment of inertia about the center of the composite body, right? Which we know is 0.18, right? So this is where we want to find the moment of inertia. So let's look at object 1. Section 1. When we look, if I wanted to find the moment of inertia about the center here, through item 1, what equation would I use? Where are we? Armando. BH cubed over
12.
12, good. How about this guy? It's not drawn to scale. JJ, what's this? So what would be the moment of inertia about the centroid of the triangle? Look on the table. Is it 1/3 BH cubed over 3? No, BH cubed over 36?
Yeah.
36? So look it up. Is it triangle 36?
Yes.
Yeah.
JJ? Yeah? Okay. So Jill, how about this one? If I